All right. Good afternoon. Oh, we have an Australian here who might actually have seen this thing live. This is a mural of Middle Island in front of Australia's coast, where a small group of Marimano sheepdogs are protecting a herd of little penguins from like foxes and other predators. And I have the privilege to own a dog just like that, which brings us to penguin herding and practical Linux automation with PowerShell, because we are at the PowerShell conference here. Many thanks to our sponsors, without whom we wouldn't be here today, at least not together. I'm Evgenij, hailing from Berlin. I used to go by CJ Berlin until they killed Twitter. Now, since Blue Sky doesn't accept underscores in user handles, I had to look for a different one, which ended up being my blog website. So all of you are welcome to visit my blog. There is not much happening there. Still, I wrote a book last year about Active Directory, and there will be a chance to win a copy in my next talk, which is tomorrow after lunch. And I pride myself in having attended all PSConfEU instances since the inception and having spoken at some of them. So, what's the plan for today? I come from the Windows part of the planet, so we will look at Linux automation and administration with Windows admin's eyes, because that's also where PowerShell initially comes from. We will look at what's being delivered so far by the PowerShell team and what is not being delivered by them. We will look at how we solve the little everyday problems everyone managing a number of systems is bound to have across networks, across distro flavors, and so on and so forth. And, of course, PowerShell is always about remoting from the very inception, and we will look at that as well. Someone could ask, doesn't PowerShell run like on Linux, on Unix and Mac as well? Yes, it does. Mac is supported PowerShell is supported officially on Mac OS and several Unix flavors, with more or less unofficially. And there are unsupported Unix distros where you still would be able to get it to run, which is almost all of them. But we will not be talking about these today. We have not enough time for Linux as it is. But we will touch on managing those remotely from a machine where you can run PowerShell in a supported sort of manner. So, managing expectations, and I already know, seeing Jordan here, that one of them will not be fulfilled. Most of our Windows people, which I will just expect us to be, who come into this talk in the hopes of getting something that would provide a more or less consistent management experience. And none of us, like I said, expectation that will not be fulfilled, are system level Linux coders, because if some were of that variety, we could create a true integration that would be talking to the kernel, would be independent or largely independent from the distro. That is not what this talk will be about. This is solving simple problems by simple means. So basically, the opposite of what LLMs do. LLMs are solving simple problems by complex means. We will be solving complex problems by simple means. Anti-LLM society here. All right. So, what's not in the box? Who remembers PowerShell Conference 2016 or the Microsoft ecosystem around 2016 in general? Microsoft used to distribute this poster. I even have that as a glossy print at home. Used to be on my wall, but then we moved house. There was not enough space on the wall for that anymore. But connector of the hybrid cloud, and the implicit promise was that you could run PowerShell on anything and remote from that anything to any other anything, and independently of where it's running in the cloud, on a hypervisor, on physical hardware, and so on and so forth. So that was the value proposition back when they introduced PowerShell Core, as it was called back then. What ended up happening? Fast forward today, if you install a Windows Server 2025, just by popping in the CD and doing next, finish, you end up having 1,800 plus commandlets in your PowerShell, Windows PowerShell. On fresh install, some of them manage capability that requires roles and features. Some of them manage things that are Windows specific, but all in all, almost 2,000 commandlets off this CD. If you install PowerShell on Linux or Mac, and this is identical, you end up with 285 commandlets altogether, of which only one is specific to those other systems. Switch process, because it mimics the function or wraps the functionality of switching the process context that does not exist on. It does exist on Windows, but it is not reflected in .NET on Windows, as far as I know. I'm not a developer. So, this is what we're looking at. And of course, this leads to the assumption that functionality might be missing in those Linux systems that we are accustomed to on Windows. To add insult to injury, .NET does not yet have feature parity on non-Windows platform to .NET on Windows or .NET and .NET Framework. So our technique that we developed almost to perfection in the last 20 years of falling back to using .NET classes when PowerShell doesn't deliver directly will not necessarily work. If .NET does not provide the functionality, .NET classes are not going to help us. So, what works well is the core functionality of PowerShell. Data types, working with objects, pipelines, parallelism, flow control, all those logical constructs work beautifully on Linux, exactly the same way they work on Windows. Working with file systems, absolutely lovely. PowerShell will correct the path separators for you. PowerShell will locate your files. PowerShell will do split path, join path, all those sort of things. You could even argue that join path might be more robust because, as many of you know, if you do not specify a Windows drive letter as the beginning of the path, join path will not check for the existence of the parent path, but that's not specific to Linux. You could create Linux paths on Windows, even in Windows PowerShell, and those would work beautifully. Or the join path commandlet will work beautifully. So this is not specific to the platform you're running on. And low-level access to data. The SQL client library that was embedded in PowerShell from almost the very beginning is still, or in .NET actually, in .NET Framework, has been ported to Linux, so you can access SQL servers directly. System Directory Services Protocol, so the low-level LDAP implementation has been ported to .NET on Unix, as they call it. So you can access directory services as long as you don't need any more advanced functionality than LDAP. And of course, things like invoke REST method also work and allow us to access web APIs, REST APIs, and anything that speaks HTTPS in the same manner we are accustomed to from Windows. So let's look at the things that are missing. I did actually not maximize my RDP session. So I split it up a bit for you. This is the diff of those 1800 plus commandlets you will find on the fresh Windows system to the 258. I took out everything that was Windows specific. But partitions, disks, iSCSI, volume formatting, these things are missing as commandlet completely. Everything related to printing, I'm German, so printing and faxing are capabilities that I require from an operating system, or at least my customers often do. I spent quite a number of days in public and finance, so printing is important. Networking, and I moved two commandlets to the front that I would actually expect it to be there on every self-respecting operating system, but those are missing. Resolve DNS name is not actually ported to non-Windows, and test net connection. Test connection is present on Linux, so basically ping. But as soon as you start testing for TCP communication and use test net connection, that has not been ported. And then, of course, the whole net adapter configuration. And I mean, Linux networking is a hot mess from the Windows administrator's perspective. The stack alone varies from distribution to distribution in a manner that is nothing short of mind-boggling if you come from Windows. And I guess it must be that way even for folks who are used to one distribution and then all of a sudden have to work with a different family. I don't know. I've never been a Linux administrator in my life. So, but all these firewall configurations, same thing. There are two rule stacks built into the kernel, IP tables and NF tables, and basically every client that is native to Linux configures both. It's just interesting. But services and scheduled tasks, both constructs are present in Linux, but the commandlets to manage those are not. So here are things that definitely should be looked at if we want to provide a consistent management experience. And then different stuff, client function, yeah, okay, SMB client, but NFS client, for example, is native to Linux. And could be even provided a management interface in PowerShell. Security, ACL, we are learning every day that file access is the basis of Linux security and is supposed to be way more secure than DP API that protects our Windows ecosystem. But local users and groups on the machine are also not ported to Linux. And things like handling time zones, certificates. This is an important one. Even stuff like new self-site certificate or get PFX data that could be implemented because that doesn't have to talk to any native security subsystem. It just handles files. Those things are missing. And of course, outgrid view and show command are missing, because those are based off Windows Presentation Foundation, which is not ported to not Windows. Otherwise, it would be a Universal Presentation Foundation or something. So stuff is missing. Let me see if I can manage to switch back to my other desktop without breaking any fingers. No, I cannot. Okay. So, these things are missing in Linux, and we have to come up with ways to provide that functionality to fellow Linux admins. How do we do that? In the best way possible. We do not reinvent the wheel. We look at what PowerShell team is doing when they encounter a situation where .NET, the underlying framework, does not deliver the functionality, and do likewise. What would that be? I grabbed one commandlet, or that is actually two commandlets in one C# file. Restart computer and stop computer. They are both present on Linux. But if we do that, let's do a little test. Here's my Rocky Linux session. PWSH, I have PowerShell installed on that. And then let me just go and do stop computer. Failed to schedule shutdown, interactive authentication required. So that reeks of elevation. Let me do the same thing on Ubuntu, and I pray that my session here, or my Ubuntu instance, has not been configured in a certain way from one of the rehearsals. Yeah, of course, I should start PowerShell first. Failed to set wall message. Ignoring interactive authentication required. So completely different return from the same command on different operating systems. But what someone who already stopped or restarted a Linux machine from an elevated SSH session knows where that is coming from. This is the output of your native shutdown command. And that is exactly what's happening here. Here's the restart computer commandlet. And there are two things that jump at us. Run shutdown with the arguments -r now. So that's exactly how you would run the shutdown command on the native shutdown command on Linux. And the other thing I wanted to point out for later is to-do. To-dos in production code are always very welcome, because you could divine from them which direction the development might be taking going forward. So support remote computer. And that is something that I would consider a no-brainer for this particular commandlet. Of course, I would like to be able to shut down a remote computer. What's the question? So basically, if the .NET does not deliver a kernel call to shut down or restart a computer, what apparently PowerShell team seems to do is to wrap native commands. That was the demo. And in wrapping native commands, we come full circle back to the early days of PowerShell. It's Monad Manifesto. What prompted the Monad Manifesto? Native commands on Windows in that case were not standardized. Some of them were localized, some weren't. The input was not standardized, the output was not standardized. So PowerShell, or Monad, is has assumed the mission of putting a common framework over all of this. How do we run a native command in Linux in PowerShell? There are different commands that we need to take care of if we're working across different distros. It's package managers. Package managers are the most diverse in my experience, but also network management and other stuff. Different commands are stored in different paths that might become necessary to know that. I will get back to that in a couple of minutes. But there is a which command, which is in the core util, should be on every distro. Actually, that will give you that path, and also will give you nothing if the command is not found on the distro, which is also very, very important to know if you're planning on running that command. And then we have the same hot mess Jeffrey Snover found on Windows back when he was hired at Microsoft. Unregulated input, unregulated output. There are some naming convention, but there is no governing body requiring people to stick to them. There are commands in Linux, and I love those very, very, very much, that allow getting JSON as output. When I see that in the manual page, my heart warms. That's the way to make things good for PowerShellers. On the other side of the spectrum, there are commands that put actionable information into the error stream rather than into the output stream. So depending on the command, you might want to consume the error stream or not. Sometimes it's very important not to consume the error stream. So there are very many varieties of this. And how do we run that? My favorite, after much experimentation, ended up being invoke expression, because that allows you to pre-provision the command line. You could use that for logging, you could use that for troubleshooting, and this is also the command with almost the least overhead in my testing, which is by no means exhaustive. But invoke expression, and that will return the standard output stream, the std out, as an array of strings with each line in a separate member of the array. So nice PowerShell thing. Allows for troubleshooting. Of course, if you start passing secrets using that mechanism, you shouldn't be logging that in its entirety, or maybe use some AI to filter the secrets out for you. Having AI calls in a logging function is a great way to slow down your execution. Fairly lightweight. Again, the overhead was acceptable in my testing, and I absolutely hate this. This is actually a good way to run a native command in PowerShell. No question about it. But I think I find that super cringeworthy, because you have to wrap your head around that every time, and also like determine what's being sent to the result. So let's get to work and recreate the missing commandlet of resolve DNS name, because everyone needs that on Linux. I will be showing everything on Windows, or the code. I will be showing the code on Windows and run it on Linux. Resolve Linux DNS name. This is a part of a module that I started creating. There are two commands, or at least two, that are very often found on Linux systems that could help us here. The first one that I like the most is dig, and the second one is hostname. Host. I'm sorry. So this is this does not cover the whole spectrum of what resolve DNS name would do on Windows, but it covers the most common scenarios, like start of authority, a name server, MX, CNAME text, and SRV records. And then you could specify multiple types, just like on Windows. And you could also specify multiple servers, which means you would also probably get multiple results. You could opt on getting raw DNS reply strings rather than formatted objects. And last one is for for very consumer-oriented Linux distribution that would not have dig or host, but would end up having ns lookup command, because that does not provide a machine-readable output. So how do we do that? Of course, we should check if we're running on Linux. If we're not, there is no point in running this. There are automated variables you can put in your script. is Linux, is macOS, is Unix, is Windows. And if all of them are null, then you're running Windows PowerShell, because those are part of PowerShell Core or PowerShell 7 in this case. So we have to determine which native command we will be using. For that, we will use which, and which will return the path. We don't need the path, but we also don't need the. We do need the path as an indicator that the command has been found, but we don't want the error message if the command has not been found, which is why we're redirecting the error stream to null. And if we were able to find dig, then we do have dig. And if we weren't, then we check for host. If we were able to find host on this system, then we will use that. And if NSLOOKUP has been found and we wanted to have an NSLOOKUP fallback, then we would end up using that. And then for each of those commandlets of those native commands, we just prepare our standard Linux command line, add servers if there are any, or use the predefined servers on the system. So this is what we will be running: dig minus t for command type, plus no all, plus answer, because we only want the answer lines, and the name that was specified. And then if we weren't doing row DNS answers or NSLOOKUP fallback, then we also pick apart these native results using regular expressions and create objects out of them. So let's see how that works. Import module, and it was the local Linux automation resolve Linux DNS name www.bullshit.de. You get objects that look more or less the same way as you would expect on Windows. So 50 lines of code, you have your resolve DNS name on Linux with all the checks and balances. If you're running on Linux in the first place, if the commands you are intending to use is present, and so on and so forth. Of course, as we saw with the native Microsoft provided stop computer, we have to deal with elevation. In Windows, it's easy. There is user access control. If something requires elevation, it will bring pop-up or not, depending on how it's configured. What do we have to contend with in Linux? There are 5 levels of elevation that we need to know about. The first one is shell is already running as root. So this is the ultimate. With great power comes great responsibility. So you can run any commands, not bothering to check if you have access rights. You have. If you're running as root, the answer is always yes. Then you are not running as root, but a user could sudo to the desired command without a password, because the sudoers facility in Linux is extremely versatile. I think I've never checked that precisely, but I think you could do everything you can do with GIA on Windows, you could do with a sudoers file on Linux, down to that same level of granularity and more. And one of the features is to allow certain commands with certain parameter sets to be run by that users as root, but without specifying a password. The next one is your standard sudo, which was the output of our restart computer command. Interactive authentication is required. There is a way to specify the password. It can be disabled on the distribution of your choosing, then it will not work. And the last two are not what we will be talking about. Users cannot sudo, but know a user who can. Then you can just switch the process or open another PowerShell shell as that user and be done with it. And of course, the situation where you cannot run the elevated command, period. How do we do that? How do we separate the first situation from the rest? On Windows, there is that require clause, require run as administrator, right? And if you are not running elevated, then the script or module will not be executed. That does not work on non-Windows. It is Windows specific. It is not secret knowledge. It's documented that is it only runs on Windows. But .NET has an environment variable is privileged process. If that is true, then you are running as root. Then you can fire whatever commands. They are very likely to succeed. If you're not running as root, you could ask for password and then just specify sudo with password. I would say the couple of seconds needed to check if I may be allowed to run it without the password are worth the while, because every time you send password anywhere in clear text is one situation more where it could be gleaned, grabbed, whatever. And if it fails, you have to specify password, provided you are sudoing or you are allowed to sudo. So we saw the native restart computer commands. Let's see if we can improve them. For that, we will be using a function, invoke. It's a version of the model that only does local execution. So please bear with me. It does not use the Linux noun here. So we will provide the return code, the lines that will return to standard out, and the lines that will return to the error stream, and at least if the invoker specified the return error switch, and then if we're running privileged as root, then we just execute the command and are done. With errors or without. Or if the user is not running as root, then there is a possibility to set a session password. There is a commandlet for that in the module. I will upload everything you see here and some of the things you aren't seeing here in this presentation to GitHub after the conference. So, but there is a different module that also does remoting, which is much more interesting, I think. And then you basically try to sudo, and to determine if you were allowed to sudo without a password or not, we're using a trick. This is a common trick in Linux. We're using a timeout command with a certain timeout. You can specify the standard values too. We're using the timeout command and trying to sudo without the password. And if the timeout timeout hits, we're assuming that we weren't allowed to do that. And then if the session password is set, we are trying to sudo with password. This is what it how it looks like. You have to echo the password to sudo -s, and of course because I don't want the password to be seen in clear text in logging and verbose output, I'm providing a second string for those usages where the password is masked by a star. So same thing. Let me see if I can. And I have the restart Linux computer commandlet here that just makes use of this elevated function. Has only one parameter now, and that is what it does. Invoke elevated command. either with now or without. I am not running elevated right now, so let's see what happens. Restart computer. Linux, in this case, it's Linux computer. Oh, the module is not loaded. Import module, local, Linux, auto. Sorry. Let me switch to Rocky because I have it imported here. Okay. Yeah, but I still don't have the local folder there. Must be the wrong snapshot. But I have the module Linux computer. Now. So it waits for 2 seconds and it will return false, which means it could not be restarted. And we're short on time, which is why I will not be showing how it works with that other thing. We will see how it works in remoting, because if you remote, you always specify the execution context, and then you don't have anything, don't have to do anything to specify the password. So, but that's how you could improve stop computer and restart computer to not have to elevate the whole shell, but to be able to elevate like one particular command. So, working across distributions, just to give you an idea of what we're up against here. There are like a number of major Linux distros. Some of them are supported officially for PowerShell, some are not. And each of them has spawned several children in the course of the decades. There are Ubuntu spawned from Debian and Kali and Mint and Raspbian, and Red Hat spawned a number of children as well. Fedora, CentOS, Rocky, and Oracle. But those are just examples. There is more. Arch spawned several ones, including SteamOS, and they all have their different package management tools attached to them. So if you want to create a commandlet for managing like software packaging universally across all those distros, these are the tools you would have to include in your execution, and they all return results in different formats, by the way. So there is a bit of work to be done to enable that experience. I provide an example of how you would do that for Ubuntu and Rocky. Same idea here. I'm determining the distribution. Oh, that is important. How do you determine the distribution you're running on? This is something that is stored in the etc OS release file, mostly. Again, there are a couple of peculiarities as to the format. Sometimes the values on the right, it's a key value, like ini file format. Sometimes the values are enclosed in double quotes, sometimes they are not. So you have to provide for both cases. And what we are looking for is ID, which is our distribution. ID like, which could be different distributions that this distribution we are on is derived from. And then version, if we need one, and the caption, the pretty name of our Linux distribution. And here, once we've determined the OS we're running on, we are either in DPKG area, which is Debian, Ubuntu, Kali, whatever. It's always worth the while to go as deep into the stack as possible, which usually will mean that you will find that tool. So for Red Hat based stuff, we are not using Yum. We will be using DNF for the very same reason, because DNF is usually always there, and Yum may or may not be. And Zipper for SUSE. Again, we're invoking the command with the appropriate set of parameters, and then we go through it line by line and create nice PS custom objects from the results. So we have 5 minutes left and one very important topic to do. Support remote computers, because of course I want to work with a different computer than what's where I am currently at. There are two ways around that. You usually have the bash shell on your Linux machine. It is usually an SSH listener in front of that, because if there isn't, then you have a problem anyway, even with native PowerShell remoting. And then PowerShell may or may not be installed on that remote machine. If it is, you could remote using SSH in the PowerShell manner, provided the automation modules, whatever you would like to run in your PowerShell is installed on that machine. You could just basically do the same thing you would be doing on Windows, provide a script block that would automate your remote session. But you could also do something else. You could modify your local module in a way that will run remote commands via SSH on the remote machine. The native bash commands or whatever commands you would be running. And that's something I would like to conclude my presentation due to time. I have lots of stuff more to show, but we are 3 minutes. We have 3 minutes left. This is a universal command invocation on a remote or local machine. So if I'm remoting, I would like to connect to a remote Linux computer, providing a credential, computer name, and then a couple of timeouts. And then I just go and connect. I also have to do commands in my code, but it's not production ready. So, I may be excused for that. And then I just create I'm using the Posh SSH module by Dark Operator here because it's available on all platforms. One of the to-dos would be to not use it, but to use some library that provide this functionality natively. But for now, I'm just using Posh SSH. And then we create an SSH connection object, determining the OS release, storing this. And this module allows you to connect to multiple Linux computers from one session. And then you have a function invoke Linux command where you just specify a computer name, and it will look up whether you already have a connection to that session and reuse the password if you need elevation, and so on and so forth. There is an elevate parameter. If you know that command has to be run elevated, you could specify a credential if it's the first time you're connecting to that computer. And then you do the exact same thing I just showed, but remotely, because there is also a way to provide password to an elevated sudo command in a remote SSH session. And that's what it looks like. And let me just, to conclude this, let me just stop my Linux machines. Oops. Yeah. That was, oh, it's Windows PowerShell. Okay. I don't know why it's doing it to me. All right. Those who know me know that I don't like PowerShell 7. Seems to work. So, code PowerShell. Computer name is 10.1.101.61. And I need a credential. There we go. There are the Linux computers I was previously connected to. It's a Ubuntu 24.204. And then I can just say restart or even stop because I'm done with my session. Linux computer name 661, and it's the Ubuntu machine. And I did not specify now, which is why the SSH session is still active. It will become inactive in a minute. Thank you very much. The call to action going on there. I will publish the current state of the Linux automation module to GitHub after the conference. The repository is already up. It's just empty. And everybody is invited to contribute. If you use some Linux commands on a daily basis, just create a wrapper for them, put it in there. Everybody can benefit.